Welcome. In this video, we're going to solve the following inequality. The first thing we're going to do is just look at when each of the absolute values in this inequality equals 0. The reason why I want to know when each of them equals 0 is because that's when they're going to have a change of sign. So we have x equal to 2, x equal to 1, x equal to 0, x equal to negative 1, and the last one over here, x equals to 3. Let's clean things up a bit, write things in the order of those roots, and set everything less than or equal to 0. So we have x minus 3, absolute value. We have x minus 2, absolute value. X minus 1 in the absolute value, minus x in the absolute value. And I'll write this next one by multiplying the 2 in. So I have 2x plus 2 in the absolute value. And if we subtract 5, the whole thing is less than or equal to 0. From here, let's write down the 6 intervals for the different x values that we can consider and the different ways that this inequality can arise. So we'll write those down now. Now, in each of the cases, the inequality that we've written down evaluates differently. The nice thing about this very first case is that we get to drop all of the absolute value symbols, because in each of those cases, the stuff inside of the absolute value is positive for those corresponding x values. So we can just write x minus 3 and a regular bracket, plus x minus 2 and a regular bracket. And we can write plus regular bracket, a minus x plus 1, changing it into regular brackets, and minus x, and plus regular bracket 2x plus 2, all minus 5, less than or equal to 0. From here, our expression above simplifies to 2x minus 7, less than or equal to 0. This means that x is less than or equal to 7 over 2. So the interval that we get for numbers that are bigger than or equal to 3 turns out to be 3 going up to 7 over 2. We can include both of those endpoints. Now, going into the next section, from 2 to 3, there's going to be a sign change on the x minus 3. So we'll no longer have the simplification down to 2x minus 7 less than or equal to 0. The change that we have to consider is that the x will decrease by 2. We're changing x into minus x. So the x went down 2, but on the other hand, the constant term, the minus 3 in the x minus 3, will change to positive 3. So we have an increase of 6 for the constant term. Now we can go ahead and simplify this case. So here we get the fact that minus 1 is less than or equal to 0. So this includes every x value in this case. So the solution set here is all of it. We get all 2 to 3, everything from 2, including 2, up to 3. So for our next interval, we'll do the same thing, collect what we have above. So we have minus 1 is less than or equal to 0. And think about the change. Now, x has changed to minus x. So again, we're going minus 2 in the x direction. And for the constant term, this time a minus 2 is changing to a positive 2, so it's going up by 4. So we can go ahead and do our simplification, and this time we get minus 2x is less than or equal to minus 3, which means that our x is bigger than or equal to a 3 over 2. So the interval that we have this time around is 3 over 2 to 2. and we can include the 3 over 2, but in this section we didn't include the 2. Okay, again, we will collect what we have from above. So we have minus 2x plus 3 is less than or equal to 0. And let's think about the change in this interval. So from 0 to 1, now we have the x minus 1 becoming negative, or there's a sign change on the absolute value for x minus 1. So we have a negative x changing into a plus x. So I'm looking right here, I'm saying, okay, that minus x will change into a positive x. So the x goes up by 2, plus 2x. The constant term, that one is going to change to minus 1, so it will go down by 2. And we can collect everything we have and finish off this section. So here we have 1 is less than or equal to 0. Here's a case where we have no solutions. There's no way that 1 can be less than or equal to 0 for any possible x value that you pick. So we'll say that there's no solutions in this particular case, and we won't include anything from 0 to 1 in our final answer once we get there. Okay, now we will collect everything that we have from above. So we have 0 x's again. In the constant terms, we have 1 is less than or equal to 0, and we'll think about the change. So in this section, now x is negative. The absolute value of x needs to have a sign adjustment. So minus x will change to positive x. The x's go up by 2. So in this case, we end up getting that 2x is less than or equal to negative 1, or x is less than or equal to negative a half. So our solution set for this portion is minus 1 to minus a half. And we get to include both of those, include minus 1 and less than or equal to minus a half, so we get to include that too. Okay, in the final step, we're starting with 2x plus 1 less than or equal to 0. And now the 2x plus 2, that last absolute value has another sign change. The 2x will change to minus 2x. X's go down by 4. And the same with the constant term. It goes down by 4. And we can work things out from here. So in terms of the x's, we have minus 2 of them. And in terms of the constant term, we have minus 3. So this means that x is bigger than or equal to minus 3 over 2. So the interval that we get this time around is minus 3 over 2 going all the way up to minus 1. Now it's time to collect all of our answer looking back. We can collect all of these intervals. Let's start by looking at smaller numbers down here, going up to the bigger numbers that we found up top. So if we look closely, we have minus 3 over 2 going all the way up to minus 1 half. That's our first interval, and we can include both of those endpoints. So in union with our next interval starts at 3 over 2, goes up to 2, picks up where 2 left off, goes to 3, goes all the way to 7 over 2. So the final interval that we need to write down to finish off our problem is 3 over 2 going all the way up to 7 over 2, and we get to include both of those endpoints. And that performs the whole problem and gives us a final answer. Thank you for listening.